Hello everyone and welcome back to another mathematics tutorial. Today I'm going to be showing you the sum rule for limits of sequences. So on the left hand side we have the statement which says that if we have two sequences, am with a limit of a and bm with a limit of b, then the new sequence am plus bn has a limit of a plus b. So you just add the limits together. I've given you an example where an is 1 over n and bn is the constant sequence 2. Then 1 over n plus 2 has a limit of 0 plus 2 equal to 2, because we already know the limit of 1 over n is 0. So it's quite easy to apply this if you have two sequences. Now I'm going to give you the proof. The proof is quite straightforward, so hopefully you'll be able to follow without too much trouble. So we're going to start by taking epsilon greater than 0, and we're going to consider an plus bn, and then we're looking at the limit a plus b. This is what we want to show is the limit. Now, what can we do? Well, let's rewrite this as an plus bn minus a minus b. So that's just expanding those brackets. Then we can write an minus a plus bn minus b. And now we're going to use the triangle inequality to rewrite this as the modulus of an minus a plus the modulus of bn minus b with a less than or equal to sign. So this is by the triangle inequality. Now what can we do? Well, this is quite useful because we have an minus a and bn minus b, and we know that a and b are the limits of these two sequences respectively. So what can we do here? Well, up here, let me write down, there exist capital N and capital M such that an minus a in modulus is smaller than epsilon over 2 for n greater than or equal to capital N. And then we can also write bn minus b is less than epsilon over 2, but this time for n greater than or equal to capital M. Okay, so this is for n greater than or equal to capital M. Okay, well now what? Well, why don't we consider the maximum of n and m? So we can say that this will be less than epsilon over 2 plus epsilon over 2 equal to epsilon for n greater than or equal to k equal to the maximum of capital N and capital M. So we're done. We're finished because we've shown that the modulus of an plus bn minus a plus b is going to be less than epsilon for n greater than or equal to capital K. So the proof is complete. Now the important step here, I'll just separate this section off so you can see, the important step here is this part, the exists capital N and capital M, because we've used the fact that the limit of an is a and the limit of bn is b. And in general it's a good idea to start by writing out the am plus bn minus a plus b in modulus, etc., and write all that out until you get to this sort of step here where you start using the triangle inequality, and then you can come back up here and you can see what you need. So once I get to here, the an minus a in modulus plus the bn minus b in modulus, I then know that I want to use epsilon over 2 and epsilon over 2 to leave me with that final epsilon. Well, I hope the proof was useful for you. If you have any difficulties or questions, do ask in the comments section, and don't forget to subscribe for more videos on mathematics. Farewell for now.